Space exploration and travel attracts a lot of people. But to do that, you need high quality engineers and people who understand the electronics which goes into the making of the several scientific payloads. I have with me Dr. Murzy Jhabvala, who's an engineer at the NASA Goddard Center and spent 45 years designing different chips. From days when there were no internet, no smartphones, to days now when mobile phones are more powerful than supercomputers. Dr. Murzy, is this the golden era of space exploration?
So that's a very good question. I think today represents the culmination of decades of space exploration, of technology development that, leads us or even allows us to start thinking about exploring beyond the Earth, even beyond low Earth orbit, to Mars, to the moon. Yeah, in that sense, it is the golden era.
You started off working with very, very tiny chips to now. How's it been an experience working with those and trying to develop detectors?
So when I first came to Goddard, the technology available was rather limited, almost primitive, but it was the most fun I ever had. And in the early days, in the early to mid 1970s, I was trying to develop the first integrated circuits really that were going to be used by NASA. And this was a very key technology at the time because integrated circuits allowed us to make things smaller, lighter weight, way more powerful electrically, and it was just the greatest challenge for me. And since then, though, in the last 45 years, the challenges have evolved. So we went from integrated circuit technology to just making single element detectors. A single element detector back then is 1 pixel. You compare 1 pixel to today's iPhone 10, which has 2.5 million pixels, and we couldn't even conceive of that iPhone 10 capability. As you mentioned earlier, from supercomputers. In the 80s, supercomputers, that was the thing. We're going to make supercomputers that can do things electronically, give us computing capability that was before incomprehensible. Supercomputers were going to take up rooms. You'd need liquid nitrogen to cool them. It turns out your iPhone is more powerful than who would have even thought of that in the 80s? We weren't even smart enough to think about an iPhone. We're thinking about supercomputers. So if you just look at that evolution, you can see that in 30 or 40 years, things have evolved so much, so advanced. It's not only mind-boggling, but as you started out saying, it leads us, and maybe every year is now the golden year because it represents such a dramatic improvement in technology that we can do things we just couldn't do the year before.
You're currently working, as you said, on the James Webb Telescope. It's going to be one of the most brilliant objects to fly, I am told. Tell us a little bit about its capability and what will it do.
So, actually, I started working on James Webb in 1998, and this was to use our technologies at Goddard in our group to develop microshutters. And microshutters are an enabling device. Just a little background here. We're not trying to make things that you can go out and buy. There's no point in doing that. We need to be able to make things that will enable NASA missions, that'll enable new science. Typically, you need 1 or 2 of those things. Nobody wants to make 1 or 2 of anything. We will. And microshutters is in that category. It's a onesie-twosie, but it's an enabling technology. And what it will do is allow James Webb, this enormous space telescope that'll be 2 million miles away. So if something goes wrong, we can't fix it. It'll allow James Webb to look way back in time. The microshutters will allow us to block all the bright objects out so they can stare really at space where we think there's nothing. But as we stare for longer and longer periods of times, we may be seeing light from farther and farther.
Same way as our eyes adjust to darkness.
Exactly. Or distance.
Yes.
And the same way that you can't see, say, the moon when it's right next to the sun. It's just overwhelmed. If we want to see a very faint object, there can't be a bright object anywhere near. So we close all these doors around the detector so it only sees the very faint or no light until eventually we integrate, is the term, enough signal that, oh, back there is an object. And another value of this is that James Webb will be able to do this for multi-objects, for maybe 100 at a time. That's remarkable. That's totally remarkable.
Let's change a little bit of the gear. You've been here, and recently the Indian Prime Minister Narendra Modi announced that India would send humans to space by 2022. As somebody who spends so much time looking at space, do you think it's a good idea, and another country joining into sending humans into space, is that a welcome addition to the family?
So, I think space exploration, human exploration, for any country is something that all the citizens can really appreciate. It creates heroes. It creates technology. Everybody can be proud of that, take pride in it. And sure, India is going to do that now. And as it turns out, I arrived here. The first thing I read in the Indian newspaper I was looking at is the Prime Minister Modi announcing that by 2022, 3 astronauts would go up on a 16-minute journey, orbit for 5 to 7 days, and then come down. And the pride that I saw when I was visiting here was incredible. And I can relate to that because when I was growing up, the manned space program, all it was heroes. Everybody loves heroes. And so India now will have 3 new heroes to love.
You mostly worked on stuff which is done through robotic systems where humans are not involved. Do you think in the long run, if human space flight takes first seat, would these robotic missions which have done great science suffer?
So that's the big question. It costs a lot of money to do this, and there's only a finite amount of money to go around. That's the question I ask. I love what I do. I love making instruments, designing, thinking up new things for instruments that go into satellites, whether they're manned or unmanned. The question is, will the focus be and the cost so prohibitive that some of these other projects may not get funded anymore just because there isn't enough money to go around for everybody? We'll have to see. I hope that's not the case. I hope we can strike a good balance so that science, pure science, still gets to happen. There's still so much for us to learn about space, about the Earth, that are done with unmanned missions. But we human beings explore. And we all, have been hearing in the news and talking about it with SpaceX, Blue Origin, Virgin Galactic, Mars One. Everybody's, we're starting to think a little bit beyond what we used to think. And Mars is the victim. So we'll see.
What is your view? Should humans colonize other planets outside the Earth system? We live in a Goldilocks zone. We are looking for another Goldilocks zone or creating a Goldilocks zone in another environment or another planetary body.
Right. So my personal opinion on that. So what I think about As an engineer and developing instruments for satellites, I have to think about details that are going to occur. And I can obsess over that. And when I think about, say, Mars colonization, I think, okay, there's a lot of technical things that have to be done. I know that. Maybe everybody else doesn't know it. Some people do. But then I start to think, okay, are we going to Mars because we have to go to Mars? Is it a necessity? Did we do something bad here where we're escaping to Mars? Because if that's the case, then I think those issues will follow us to Mars. Or are we going to Mars because as human beings we love the adventure? We love the challenge of exploring. We're going there with a clean slate. This is something that I think about. I don't know if a lot of people are thinking about it, but I hope we're not going to Mars because it's an absolute necessity.
So we should go to explore?
In my mind, it's for the exploration, which is what all the satellites I've worked on are out there. We don't know what we're going to find. We're going to go explore for the sake of science. That's where I'm coming from.
When you talk of exploration, and it's an obvious question in the minds of lay people, do you think life in one form or the other also exists somewhere other than Earth?
I do, somewhere. I mean, it could be very far away, thousands, millions of light years away. But the probability, the numbers just say it almost has to be out there. Whether we'll ever encounter it, or even if it's occurring within the same time slice as we are. We've been, our solar system's 4 billion years old. Maybe life occurred 3 billion years ago in some other place. I mean, there's a lot of factors that have to converge for us to actually encounter another life form. But yeah, I think it's out there somewhere.
You're positive about the future of exploration?
I'm positive that human beings want to explore. I hope that we as a human race can keep that option open to us.
That was Dr. Murzy Jhabvala, a renowned engineer from NASA, who gave us an insight on how difficult or easy it is to make detectors, but also gave us an insight that if we have to colonize other places, it should be to explore and not out of necessity that we did something wrong on Earth and we were forced to go elsewhere. A noble thought. I hope the world listens to this thought carefully and we go ahead and colonize for reasons of exploration. In Guwahati, Pallava Bagla.